first we need to identify the two pieces or the two ions. It should be fairly simple now because we're only doing binary ionic naming. Binary meaning two ions. It will get a little bit harder. I know this is a bit of a repeat, but I'm trying to make sure you really get used to this definition of cation for our positive ion, anion coming from our negative ion. Convention is we always write the positive ion first and we always write the negative ion second, no matter where it comes from. So that's why you keep seeing this list and you keep seeing it in the exact same order. Okay. We're going to name the cation first by using the unaltered metal name. We're not going to do anything to it. You're going to go to your periodic table and write it exactly as there. To get the anion name, you're going to get the anion name by dropping the ending of that atom and adding "-ide". Okay? That's how we switch a non-metal from the atom to the ion. Often students are wondering, why am I saying fluorine sometimes and saying fluoride other times? Fluorine is going to be the atom, exactly as in the table. When I drop the ion and add "-ide", now I'm talking about F-, the ion. And that's what we do when we name ionic compounds. We drop the last 3 or 4 letters and switch the ending to "-ide". So a name you probably know already just from common language. And we do use the IUPAC scientific name for this. Na is sodium. So we're just grabbing that metal name. It is an ion, but the name doesn't distinguish between atom and ion. Okay? It's just sodium, but it is sodium plus. Cl as an atom is chlorine. Don't write this all yet because I have to switch some stuff. That's the anion, the atom that created the anion, and we have to drop the ending, drop the last 3 letters, and we switch the N to "-ide". Okay. So sodium chloride that you're probably used to. CaO. Ca is calcium. So I'm just going to the periodic table. Okay. I'm faster at naming stuff because I kind of know where things are at. The slowest part for most students right now is finding where the atom is. You may or may not be used to finding things in the periodic table quickly. The more you practice, the faster you'll get at this and the faster your quizzes and tests will go in homework. O is oxygen. Don't write oxygen yet, please. With oxygen, often how many letters get dropped is due to phonetics, making sure it sounds okay. With oxygen, if you only drop 3 letters, you get the same sound back to back, the Y and the I. And it just doesn't work for pronunciation purposes. So oxygen, we drop 4 letters. So it becomes oxide. Last example before you'll be practicing some of these binary naming. Al3N2. Okay? The subscripts have no effect on the name. Okay? Al is aluminum. The 3 does not show up if it's ionic. Okay? N is nitrogen. And in nitrogen, we drop the last 4 letters. And it becomes nitride. So kind of like oxygen, most of the time it's 3 letters, but occasionally it's 4. All of group 7 is nice, it's always the INE. Oxygen and nitrogen, you drop the last 4 letters. Sulfur, you only drop 2, becomes sulfide. Okay? With practicing and looking at examples, you'll pick up those little nuances of whether it's 1 more than 3 or 1 less than 3 or 3, which it is most of the time. In the later lesson, nitrate is NO3 minus. It's one of those polyatomic ions. Yeah. Nitride is coming from nitrogen by itself. Anytime the ending is ate or ite, it's polyatomic. It's coming from a group of atoms that make up an ion. Okay? So it'll be in our notes shortly. Carbonate, that 8 ending, CO3, 2 minus. This 2 minus isn't the O, it's the whole CO3 is 2 minus. So it's polyatomics. That's 2 sections ahead in today's lesson. So I want to give you a chance to practice some naming. I have that same list that I put up before. So you might already have these in your notes. You could add the name right next to those formula units that you balanced. Okay. So balance and name, you've done all of these, exact same list. Okay. Hopefully maybe you have room in your notes to name next to them or just write them out again.